Welcome back to Jack of All Pools for our next module. In this section, we're diving into the basics of pool chemistry. Don't worry, you don't need to be a scientist to understand this stuff. I'll break it all down in simple terms, so you know exactly what your pool needs to stay clean, safe, and crystal clear. You'll learn about the key chemical levels to monitor and understand what each one does. Let's get started and take the mystery out of pool chemistry. Think of your pool as a recipe. Every ingredient matters. Too much or too little of one thing can throw everything off. To keep your water clear, safe, and balanced, there are a few key factors you need to keep an eye on. The main ones to monitor are pH, chlorine, total alkalinity, calcium hardness, cyanuric acid, also known as stabilizer, and of course, salt. These elements work together, kind of like gears in a machine. If one gear slips, the others can get out of sync, and that's when you start seeing cloudy water, algae blooms, or skin and eye irritation. Up next, pH, the foundation of balance. Let's kick things off with one of the most important factors in pool chemistry, pH. So, what is pH? pH stands for potential of hydrogen, but don't worry, you don't need to be a chemist to understand it. All you need to know is this. pH tells us how acidic or basic your pool water is using a scale from 0 to 14. A pH of 7 is perfectly neutral. Below 7 is acidic, kind of like vinegar or lemon juice. Above 7 is basic, also called alkaline, more like baking soda or soap. For pool water, the sweet spot is between 7.4 and 7.6, with a safe range of 7.2 to 8. Up next is chlorine, your pool's main defense against germs. Now that you understand pH, let's move on to the real hero of pool water safety, chlorine. Chlorine is a sanitizer. Its job is simple. It's responsible for killing bacteria and germs, preventing algae from growing and breaking down oils, sweat, and other organic material. There are 3 chlorines to measure in your pool. Let's start with free chlorine. This is the good stuff. Free chlorine is active, available, and ready to kill bacteria, viruses, and algae. It's the chlorine that's doing the work right now. When you test your water, this is the number you want to pay the most attention to. Next is combined chlorine, also called chloramines. This is chlorine that has already reacted to contaminants, things like sweat, urine, sunscreen, or other organic materials in the water. Combined chlorine doesn't sanitize anymore. It just floats around, used up, and it's what gives pools that strong chlorine smell and causes skin irritation. And finally, total chlorine is simply the sum of both. Free chlorine plus combined chlorine equals total chlorine. In a well-balanced pool, free chlorine and total chlorine should be the same or very close. That means there's little to no combined chlorine, and your sanitizer is working properly. But if total chlorine is much higher than free chlorine, the difference is your combined chlorine, and that's a sign you need to take action. Here's the catch. Chlorine can't do its job well if the pH is off. If pH is too high or too low, chlorine becomes less effective even if it's in the water. There is also another important relationship with chlorine, and that is cyanuric acid, or CYA. Cyanuric acid helps keep chlorine in your pool, and we will talk more about that in more detail soon. But keep in mind that there isn't a set target for free chlorine, but rather it's relative to your CYA level. For saltwater pools, the target free chlorine levels are shown in the table here. Remember, those targets are relative to your cyanuric acid level. You'll notice that CYA levels below 60 and above 90 are not recommended. You've learned about pH and chlorine. Now let's introduce total alkalinity, the unsung hero of pool chemistry. Think of alkalinity as the bodyguard for your pH. Its job is to keep pH stable and prevent sudden swings that can throw off your whole chemical balance. Total alkalinity measures the amount of buffering minerals in your pool water, mostly bicarbonates. These buffers soak up changes in acidity or basicity, making it harder for your pH to jump all over the place. Without good alkalinity, even small things like rain, pool shock, or a splash of sweat can cause big pH swings. The sweet spot for total alkalinity is shown here. Up next, we'll talk about calcium hardness and why your water needs some calcium. Calcium hardness is key in keeping your pool water balanced and your surfaces protected. Calcium hardness refers to the amount of dissolved calcium in your pool water. It's one part of what we call total hardness, And it's important because it affects how water interacts with your pool surfaces and equipment. The target ranges for calcium hardness will depend on your pool type. The ranges for various pool types are shown here. Your calcium level tends to stay fairly stable. It doesn't evaporate, but it can build up if you use hard fill water or certain pool chemicals. Balancing your calcium hardness helps protect your pool and equipment and keeps your water looking crystal clear. It's one of the easiest levels to manage, but one of the most expensive to ignore. Up next is cyanuric acid, your chlorine's secret weapon against the sun. Let's move on to another important, but often misunderstood, part of pool chemistry, cyanuric acid, or CYA. It's also referred to as stabilizer, so you may hear both terms, but they mean the same thing. Cyanuric acid is like sunscreen for your pool's chlorine. When chlorine is exposed to sunlight, especially in outdoor pools, it breaks down very quickly. In fact, unprotected chlorine can lose up to 90% of its strength in just a few hours of direct sun. That's where CYA comes in. It binds to the chlorine and helps it stay in the water longer, so it can keep doing its job, which is to keep sanitizing your pool. The target range for CYA is shown here. When your chlorine levels are too low, it's possible your CYA is not sufficient. A general rule of thumb is that your free chlorine should be about 10% of your CYA level. For example, a CYA of 70 should have a free chlorine level of about 7 parts per million. You might have heard people say saltwater pools don't use chlorine, but that's not true. In fact, salt pools make their own chlorine right in your backyard. Let's break it down. A saltwater pool is still a chlorine pool. It just uses a salt chlorine generator to make chlorine instead of you adding it manually. You add pool-grade salt to your water, and the salt level stays relatively stable over time. The salt system, or chlorinator, then converts that salt into chlorine using a process called electrolysis. Inside the salt cell, an electric current passes through the salty water. This triggers a chemical reaction that splits the salt, sodium chloride, into hypochlorous acid, which is the same active sanitizer in traditional chlorine products. The result: fresh chlorine is constantly produced and circulated in your pool. Most salt systems work best when the salt level is in the range of 2,700 to 3,400 parts per million. Let's summarize what we've learned about all these factors, their functions, and the target ranges. Let's do a quick recap of the core elements of pool chemistry you've learned so far. pH measures how acidic or basic your water is. You want to keep it between 7.4 and 7.6 for swimmer comfort and chlorine efficiency. Chlorine is your main sanitizer. You learned the difference between free, combined, and total chlorine, and why free chlorine is what really matters for sanitization. Total alkalinity stabilizes your pH, helping prevent big swings. It's like a buffer that keeps your water balanced. Calcium hardness helps protect your pool surfaces and equipment. The ideal range depends on your pool type. Cyanuric acid acts like sunscreen for your chlorine, protecting it from the sun. Salt systems generate chlorine automatically using dissolved salt and electrolysis. Now that you know what each chemical does, let's talk about how to manage them. In the next module, we'll cover what happens when levels are too high or too low, and exactly what to do to bring them back in balance.